One of the most fascinating astronomical events is the potential supernova of Betelgeuse, located in the famous shoulder of the constellation Orion. Betelgeuse is a red supergiant star nearing the end of its cycle. Surprisingly, in 2019, one of the brightest stars in the sky began to fade noticeably, becoming visible even to the naked eye. For several months, its brightness decreased so much that many observers wondered if the star was dying. Turning their telescopes toward the giant star, scientists were astonished by the evidence of the great dimming. Betelgeuse is believed to be close to becoming a supernova, indicating the end of its life cycle. But when and why will the stellar explosion occur? Could it have devastating consequences for Earth? The glowing ruby star Betelgeuse lies on the upper right shoulder of Orion the Hunter. You may recognize it by its other name, Alpha Orionis. Although it is the second most brilliant star in its constellation, behind the supergiant Rigel, it remains one of the most interesting to astronomers because of its variable behavior and peculiar name. Alpha stars are usually the brightest stars in their constellations. Although Rigel outshines it in brightness, Betelgeuse stands out for its size and reddish color. Betelgeuse, also known as Alpha Orionis, is one of the most famous stars in the night sky, being the 10th brightest and 7th brightest visible from much of North America, Europe, and Canada. Its name comes from Arabic and means armpit of the giant, in reference to its position in the constellation. Betelgeuse loses about 1 solar mass every 10,000 years, ejecting materials evenly in all directions and forming a nebula around it. This nebula has a diameter of 30 astronomical units, 30 times the distance between the Earth and the Sun, and is 250 times larger than the star itself. At its core, Betelgeuse's hydrogen atoms fuse into helium, producing immense gravity and releasing light and heat in the process. As the star exhausts its hydrogen, it begins to fuse helium and carbon as fuel. When the helium is consumed, neon reacts with carbon, forming iron. The fusion of iron releases no energy, causing the star to collapse under its own gravity and eventually explode in a supernova, one of the most powerful explosions in the universe. Depending on their age and evolutionary stage, stars emit light in different wavelengths, from the bright blue of young stars to the red of older ones. According to the ancient astronomer Ptolemy, Betelgeuse had a color he referred to as curiously ruddy. However, ancient Chinese astronomers noted that Betelgeuse appeared to have a yellow color, suggesting that in the past, it may have been a yellow supergiant. Large stars tend to consume their hydrogen rapidly, bringing them to a premature end, even if their lifetime is only 10 million years. There is no doubt that Betelgeuse is in the last stages of its existence. While our Sun still has more than 5 billion years to go, Betelgeuse is getting close to dying, which means that, at some point, it could explode as a supernova. However, the exact timing of this event remains uncertain. Betelgeuse goes through 2 brightening and dimming cycles, one of which occurs every 5 years and lasts about 100 days. It is believed that the expansion and contraction of its outer shell during these cycles causes changes in its diameter and average temperature. Many paid attention to Betelgeuse because of its erratic behavior in 2019 and 2020, when its brightness decreased dramatically, only to recover temporarily. Some astronomers have speculated that this behavior could indicate that the star is in the final stages of its life. Detailed studies of Betelgeuse date back to the 1st century BC, but the cause of its dimming remains a complete mystery. Betelgeuse has been detected moving through the interstellar medium at a speed of 30 km per second after being ejected from its place of origin in the Orion OB1 association, which contains the stars of Orion's belt. The shock arc extends more than 4 light-years. Determining the distance to red supergiant stars like Betelgeuse is a notoriously complicated task in astronomy, as multiple factors make it difficult to calculate its exact diameter. In addition, as a pulsating star, Betelgeuse's size changes with time. This phenomenon, together with the dimming of the stellar limb, causes its visual emission to dim and change color as we move away from the star's center. In addition, the circumstellar envelope, composed of the material ejected by the star, plays an important role in emitting and absorbing light, which also influences how we perceive its brightness. Direct comparisons between observations of Betelgeuse are difficult to make, as its apparent size varies depending on the wavelength used. Diameters can fluctuate by as much as 35% depending on the wavelength that is used to measure them in the electromagnetic spectrum. In July 2009, the European Southern Observatory published images captured with a VLT interferometer, with respect to its base telescope, showing a huge plume of gas extending up to 30 astronomical units from the star's atmosphere, one of multiple mass ejections recorded from Betelgeuse. This ejection was comparable in size to the angular separation between the Sun and This ejection was comparable in size to the angular separation between the Sun and the planets in our solar system as seen from Earth, highlighting the immense scale of the phenomenon. These mass ejections are believed to contribute to the irregular dimming of Betelgeuse by creating dust clouds that temporarily obscure the star's light. In fact, one leading theory for the 2019 to 2020 Great Dimming suggests that a massive outburst of material formed a dust cloud that cooled and condensed, blocking part of the star's surface from view. Although Betelgeuse is located approximately 500 to 700 light-years away, a supernova of this magnitude would still be visible from Earth, potentially even during the daytime. When it does explode, it could shine as brightly as the full moon and remain visible for several weeks or months. However, experts reassure us that the explosion would pose no direct danger to Earth due to its distance. Astronomers continue to closely monitor Betelgeuse using space-based telescopes, infrared imaging, and spectral analysis. These observations help track surface activity, measure its pulsation cycles, and detect any new outflows or structural changes in the surrounding nebula. Whether Betelgeuse explodes tomorrow, in 10,000 years, or later, its life is a dramatic testament to the final acts of massive stars. When the time comes, it will offer humanity a rare opportunity to witness a nearby supernova, one of the universe's most awe-inspiring natural events. Neptune, at least 6 around, ejections have been discovered. Betelgeuse, this phenomenon may offer hints to the mystery of the widespread mass loss in the final phases of these giant stars, which could be the key to their demise. The complex dynamics of Betelgeuse's extended atmosphere remain an enigma, as does the exact mechanism by which these red supergiants eject material. These stars are essential to the cycling of matter in galaxies, and thanks to advances in interferometric techniques, astronomers are closer to solving this enigma. In 2019, researchers using the Hubble Space Telescope and other instruments discovered that Betelgeuse had ejected a large portion of its visible surface, generating a significant surface mass ejection, SME. Although the Sun produces coronal mass ejections, the events at Betelgeuse were thousands of times more intense. This SME ejected an amount of material 400 billion times larger than a typical solar coronal ejection. This explains why Betelgeuse experienced a rapid decline in brightness in October 2019. By the middle of February 2020, it had lost about 2/3 of its luminosity, going from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had remained relatively stable for more than a week. On the 5th, it appeared that the star had stopped dimming completely. However, the recent visual fades were not related to the possibility of core collapse, as no significant infrared changes were observed. On February 24, 2020, it became clear that Betelgeuse was not going supernova, yet. Let me know what you think in the comments box. If you liked the video, hit the like button and subscribe so you don't miss out on more content like this one. When Betelgeuse finally explodes in a supernova, it will be one of the most spectacular celestial events in recorded history. Despite being 640 light-years away, the explosion will be so bright that it could outshine the full moon in our night sky and even be visible during the day, for weeks or possibly months. Astronomers estimate that the supernova will release more energy in a matter of seconds than our Sun will during its entire 10 billion-year lifespan. The light from the explosion will race across space and eventually reach Earth as a brilliant point of light, unlike anything we've ever seen. But don't worry, we're completely safe. While a supernova that close might sound dangerous, Betelgeuse is still far enough from Earth that the blast won't harm our atmosphere or life. What it will do, however, is provide an unprecedented scientific opportunity. As of recent years, Betelgeuse is back to its normal levels of brightness, but its irregular dimming cycles continue to be monitored closely. Instruments are being used by scientists, like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based interferometers like VLT and ALMA. They're observing fluctuations in surface brightness, convective cell patterns, and persistent mass loss events that seem to signal the star's instability. One popular theory is that Betelgeuse's great dimming was caused by a massive cloud of stellar dust created during one of these outbursts, temporarily blocking the star's light from our point of view. Understanding Betelgeuse could help astronomers unravel the life cycles of massive stars, especially those nearing supernova. This knowledge could help us predict similar events in other galaxies, understand the universe's chemical enrichment, and learn how elements like gold and iron are formed and dispersed through space. Betelgeuse is basically a fantastic time bomb, and it's ticking slowly. It may explode tomorrow, next year, or in 100,000 years. But whenever it does, it will offer us a cosmic light show and a scientific treasure trove unlike anything in recent memory. As Betelgeuse continues to captivate both scientists and the public, it serves as a reminder of the dynamic and unpredictable nature of the universe. Every observation brings us closer to understanding not just this single star, but the life cycle of massive stars across the cosmos. Its eventual explosion will not only mark the end of its life, but also provide valuable insights into stellar evolution, the formation of elements, and the fundamental forces that govern the universe. In the meantime, researchers will continue to monitor Betelgeuse, using the latest technology to analyze its behavior in real time. The lessons learned from Betelgeuse will shape our understanding of other supergiants, potentially allowing us to predict the behavior of similar stars in different parts of the galaxy. Though Betelgeuse's end is inevitable, it will leave behind a legacy of discovery, offering us a glimpse into the processes that shape the very fabric of space. Whether we witness its final moments in our lifetimes or from the distant future, the event will undoubtedly echo throughout the ages, a testament to the remarkable forces that govern the universe. Until then, we can only watch, wait, and marvel at the mystery of one of the most enigmatic stars in the sky.